The Encyclosphere. We want networks that hand back full control to individuals. But if your content lives on a decentralized network, how do you make sure that only you maintain control over it? This is an old problem, with an old solution. Consider a new variant on the old solution. It's published by the World Wide Web Consortium, which is the big Internet standards body. It's called the DID specification, or Decentralized Identifiers. One particular implementation of that specification is called DID PSQR. The last bit stands for public square. It defines a distributed identity that you can use anywhere in a truly open, truly decentralized public square. The DID PSQR specification works a lot like a system you probably use every day. You know the lock next to web addresses? You might have noticed it. That lock means the website uses the relatively secure HTTPS protocol rather than the older HTTP protocol. If you click on the lock, you're told that your connection to the website's server is secure. That means the website has a certificate, and your browser recognizes that the certificate is valid. That means that you know the information coming to your browser actually did come from where it looks like it came from. In other words, nobody is spoofing the website. Nobody is cleverly impersonating it. So, the HTTPS protocol is an identity system for whole websites. The way this sort of identity system works is a bit technical for the general public, but most programmers understand it. These details really are important. This is something everybody should probably know about, not just programmers. So let's get into it a little. If you spent much time on a command line, you might have heard of key pairs. This is a pair of codes which fit together in a certain way. In a key pair, one is public. It's typically used for some kind of communication. It operates like an email address or a Twitter handle. You can give this piece of code out to other people. The other bit of code in the pair is private, so it operates like a password that only you have. You keep this secret and safe. Both the DID PSQR specification and the HTTPS protocol are based on something called key pair cryptography. Because of the relationship between the public key and the private key, two things become true. First, I can use my private key to take something I've written and translate it into a mysterious, unreadable code. But because of the way the key pair works, this mysterious code can be deciphered by anyone with my public key. That's the way key pair cryptography works. More specifically, how public and private keys relate to each other. Anyone who deciphered my encoded message would know I had to have written it, because only I had the private key that would encode the message in a way that my public key would unlock. Neat, huh? Well, it's neat if you understand it, and it's very useful when proving that people are who they claim to be. Second, anyone with my public key can also produce a mysterious, unreadable code, and nobody could read it, except me, when I unlock it with my private key. That means someone could send me a secret message that only I could read. If I produce the original text, then I've proven that I have the private key. So, what does this key pair cryptography have to do with decentralized identifiers? To reiterate, it is an identity system we're proposing to use for decentralized content networks like the Encyclosphere. Why does the Encyclosphere need an identity system? If a person wants to sign their name to an article they authored, and their personal identifier is like an email address, they add their name and personal identifier to their article. But then anybody could write that on an article and claim to be that author. Not good. What's needed is a trustworthy method of signing the article in a way that confirms it was by the author. How? Well, suppose you run a little cryptography program on your server. The program takes the article, or maybe the whole ZWI file, as an input, and outputs a complex code which looks like a long password called a hash. Anyone could take the same file and run the same program and get the same hash. Next, the little cryptography program takes a second step. It takes the hash as an input, and then uses your private key to spit out another code, which only a private key could get from the hash. We could call this second code your signature, because only your private key could generate it. It works like the padlock on the website, but what it's confirming is that you authored that particular ZWI file. You add that second code to the ZWI file itself, and it becomes a more reliable signature called a cryptographic signature of your document. But how could you use that signature to prove the author actually signed it? By running another little cryptography program on your own server. It takes two inputs: the signature you added to that ZWI file and your public key. The program spits out the hash of the ZWI file because of how the public-private key pair work together. So you use the author's public key and signature to get the original hash, which we saw previously without using the original ZWI file. But anybody can also get the same hash from that original ZWI file and compare them and see that they are identical. So that proves mathematically, or cryptographically, that only the author's private key could have produced that signature. I realize it sounds like a lot of technical mumbo-jumbo, but here's the bottom line. You can prove to the world that a file that is floating out there online in a decentralized network, or anywhere else for that matter, actually belongs to the author, because their private key signed it. That matters because then everyone on the network can trust that any future changes to the file should be respected, if they come from the author. The public-private key pair can work as your own identity. It will work absolutely anywhere, and it doesn't depend on Google or Facebook or Twitter. You can also sign information about yourself and attach it to your identity. For example, I can include a list of the people that I follow. Nobody can edit that list but me. I own it. I can also include a profile picture that only I control. I can add a bio, and so forth. How does this identity system work in the context of the Encyclosphere? We'll go back to the case of an individual author wanting to upload an encyclopedia article they've written, being able to upload new versions of the article, and making sure no one else takes credit for their work. How does the identity system help with that? To begin with, the KSF will be creating a plugin for WordPress, so if you upload an encyclopedia article to your blog, you'll be able to push the article to the Encyclosphere with the press of a button.